Hello, let's try a slightly more difficult example, not much, almost the same, but let's now say we have an m by n board. So what we're going to do is we're going to say we have a situation like this, okay? And what we're going to do now is we're going to find the Rook polynomial again. So how could we do so? Well, the number of ways to place 0 rooks is obviously going to be 1. How many ways can we place 1 rook? Well, let's see. I'm going to choose 1 row. So that's going to be m choose 1. And then I'm going to have n choices there. And that's going to be the coefficient of x to the 1. These n choices are for the column. Now, suppose I want to place 2. Well, I'm going to choose 2 of the rows, and now I'm going to have n choices for whichever column I pick from the first row, whichever row comes first, and then n minus 1 for the next. So I'm going to have pn2. And this is going to go on and on up until eventually when I get to m, I'm going to have m choose m, and I'm going to have p and m. And of course, from the picture you could see, though I didn't specifically say that my n is greater than or equal to m here. Of course, remember that's the number of ways to place m rooks. And we can't place more than m because we only have m rows on the board. So this is our solution. And what do we get? Well, we get k equals 0 all the way to m of m choose k, p, and k, x to the k. And that's our formula for the m by n board. Okay, but what if we have a board like this? And let's make it like this. Let's just do this. Shade that, and let's try shading that. Okay, so now this is my board, and I want to find the Rook polynomial. So let's say I'm trying to find the number of ways that I can place k rooks. That's going to be the coefficient of x to the k. And I want to find the number of ways I can place k rooks. Well, I can find the Rook polynomial of this very easily and this very easily using these formulas, this one up here or the one that we used last time. But is there a shortcut? And I want us to think about this. Let's say I wanted to place, I don't know, let's pick a specific number to make it easier, 3 rooks. Okay? So I could either place all 3 rooks here, or I could place 2 rooks here and 1 here, or 1 rook here and 2 rooks here. And actually that's all. I can't place 3 rooks here. But I could say I'm going to add up the number of ways. I could put 0 rooks here and 3 rooks here, and I'd just be adding 0. So what did I just do? I broke this down into cases. And this is only because this board doesn't affect this board. If I change the board by doing, say, something like that, or it doesn't have to be connected, let's say I do this. Now I can't make the same argument because what spot I use to place a piece here, well, that might affect the choices I have left here. But in this sort of situation, we could say the choices for one don't affect the choices for the other board other than the number of rooks which are left. Okay, so let's say I have a Rook polynomial for here and a Rook polynomial for here. So I have 1 plus r1x plus r2 x squared plus r3x cubed for this board, and I have 1 plus s1x plus s2x squared for this board. Okay, and now let's try to find the number of ways to place 3. Now, we already know that our placement, our spot, doesn't affect the possibilities for the other board. So for example, let's say I place 3 rooks here and 0 rooks here. Well, what am I going to get? I'm going to have R3 times, well, this is 1, or S0. So I'll just write that. Okay, how many ways could I now place 2 rooks here and 1 rook here? Well, that would be R2 times S1. R2 times S1. Okay, well, how many ways could I place 1 rook here and 2 rooks here? Well, that's going to be R1 and S2. And I'll toss it in. How many ways could I place 0 rooks here and 3 rooks here? Well, that would be R0, S3. And I know this is 0 because S3 has to be 0. Have you seen anything that looks like this before? A sum like this where one thing is going down and the other thing is going up? Well, let's look at the product of these two. And I probably should write this as R0 and S0. Okay, so let's say I take this product and I want to find out what I get. Well, it's going to be a polynomial and it's going to be degree 5 because the highest thing I could get here. And I'm going to start off by getting, well, R0, S0. And then I'll get the coefficient of x to the 1, which would be R0, S1 plus R1, S0. And why is that? Well, the only way I can get a total of 1x is if I use these two and these two, or these two. So 2 possibilities there. And now for the coefficient of x squared, well, I could use, say, R0 and S2 plus R1 and S1, or R2 and S0. And now for the coefficient of x3, well, or x to the 3rd, what could I get? Well, I'll have R0 and, well, S3, which is just 0, but I'll write it in anyway. And then I'd have R1 and S2, and then I'd have R2 and S1, and R3 and S0. And that would be the coefficient of x cubed. Wait a second. Notice something? What did I have here? I had that for the ways to place 3 rooks. And what do I have here? I have the same exact formula, because this is exactly what multiplying polynomials does. It takes the coefficients from the 2 different polynomials that correspond to a total of k. So if I want the coefficient of x cubed, I'm going to be taking the coefficients that correspond to a total of 3. And that's exactly what we want if I want to find the number of ways to place 3 rooks. What's the number of ways to place 2 rooks on this board? It's going to be that coefficient. Number of ways to place 1 rook, that coefficient, and so on and so forth. So, if I have a situation like this where I have a board where the positions don't affect each other. What do I mean by that? I mean no space on this board shares a row or column with any space on this board. Then I can just multiply the 2 rook polynomials. So I can use polynomials in order to solve my problem. We'll talk more on this coming up.